So how many of you guys have heard of R3 before? Couple? Okay, I would hope so. They're doing a class right next door to us. So R3 is also a consortium, as Solomon mentioned, built up of financial institutions. They have a motto, adopt, adapt, or build, which I'll get back to in a few minutes here. It was started by a gentleman named David Rudder. David Rudder worked a long time in Wall Street, had helped put together kind of large consortium or team efforts around financial products previously. And he was one of the first people, not one of the first people, one of the first to really take an initiative within the traditional finance world to point out that the underlying technology of Bitcoin blockchain could be used for purposes within their landscape as well. And it's not just this one single cryptocurrency. So basically, he got a large consortium of banks together. I think it's over 100 banks today. But late 2018, so late 2016, they had announced that they are going to try and raise $150 million. And basically what the pitch is instead of each individual bank going out and doing their own proof of concept around blockchain, right? Let's all come together and create a few labs around the world and all work together on these, because if one of us figures out like this good project, the whole goal is to have it be interoperable, right? And be able to reconcile differences easier and things like that. So they got this large consortium together, said let's raise $150 million to create these labs and start pumping out these proof of concepts and things like that. Shortly after they announced that they were going to try and do this fundraising round, Goldman Sachs publicly announced that they're dropping out of the consortia. Like 2 days later, Santander dropped out, and then a couple days later, JP Morgan and a few other big banks dropped out as well. So for a week or two there, it wasn't looking so hot for R3, but they still have, like I said, a very large consortia of some of the largest financial institutions in the world working with them still, and they have these labs and are going out training developers on how to build on Corda, which is what I'll get to right now. So two of the guys kind of tasked with leading up these projects and what the labs would be working on are Richard Brown and Mike Hearn. Richard has one of the, worked at IBM for a while. He has one of the best blogs in the industry. I would highly recommend checking it out and giving it a read. It's in the resources section in the back, the name of the blog. Mike Hearn worked for Google for a while, and he was one of the Bitcoin core developers. So that's one of the select people that can actually submit code to the core Bitcoin blockchain. And so he was working on that for a long time. A lot of the drama and kind of political strife that was happening within the Bitcoin community that Solomon alluded to earlier is one of the big reasons he left. He was kind of over the nonsense that was going on over there. And so they were tasked with coming up with, what type of projects are we going to work on? And that's where that motto comes back into play, the adopt, adapt, or build. So they were charged at looking at the current implementations like Bitcoin and things like that and seeing, can we just take this and use it completely as is? That obviously wasn't the case with, the pseudonymity, can never get that word right, anonymity with Bitcoin. And then, can they adopt some of it though, or adapt some of it for what they need, and then build the rest kind of around their particular use cases that they want within the finance industry. And so the platform that they're building is called Corda, and Corda, C-O-R-D-A, is a distributed ledger and not a blockchain, okay? I'm gonna go through what that difference is right here. So first, we're going to talk about a distributed network, which you guys probably have heard of. It's been around for a while. And in this example here, you have these 4 different nodes. These could be different, computers in different locations, but they're all part of the same bank, okay? They're all part of the same network, so they all inherently trust each other. They're inside this red circle. Everybody trusts the other computer, and so they can send data back and forth pretty freely and not have to worry about, who's receiving what. So this is just an example of a normal distributed network, which has been around for a while. What they're kind of doing is a distributed ledger, and it's a distributed network, but But the partners in the network don't inherently trust each other. They inherently do not trust each other, and they don't want the information to just flow around, right? So a way to visualize this is if right in the middle here, in between the four of them, there was a blockchain, a single source of truth, right? Then everybody in the network would be able to see what's happening. And that's not going to work in the finance industry. I don't want to publicize all the deals that I have and the transactions that are going on, right? So the way that they kind of figured out a way to have a distributed network but not make all the data public to everybody in the network was to essentially come up with I call it like a filing cabinet for each individual node or member of that network, okay? So if it was a financial situation, you could think you might not be able to see the names great, but it says Richard, Albert, and Harrison underneath these filing cabinets, right? So they're all individual players in this network that don't inherently trust each other. They don't want everybody knowing all the data and transactions that they have, okay? So what happens is, you get a filing cabinet of a record of all the transactions that you've been a part of or been permissioned to see, okay? So in this example right here, you have Richard right here and Albert is the middle one, and they enter into a transaction and we call that transaction number 128, right? So they both have a history of that entire transaction, the back and forth, the reconciliation process until that's closed out, okay? Now they enter into another transaction a couple days later, let's call that number 132, and that goes on for a little while and they have records of that, and then that closes out, okay? Now, let's say a few months later, Harrison, way down there on the end, he wants to make a deal with Albert in the middle there, okay? And their deal is gonna be number 140, okay? But deal number 140, in order to execute that, or for Harrison, the one on the end there, to know that this deal is like valid, he needs prior information, which is in deal number 132, which he wasn't originally a part of, right? Just Richard and Albert were a part of that deal. So Harrison had no idea that even happened. He's in the network, but he doesn't hear about anything unless he's a part of that transaction itself. In order to get the information for deal 132 so that they can execute on deal 140, Albert and Richard can allow him access after the deal has happened, essentially, grant him post access, so that now Harrison can review the deal documents in 132 and ensure that, yes, the information that I needed from here is correct, and now we can proceed with deal number 140 now that I have that. Right? And he gets to now keep that in his filing cabinet for records as well. And so this is a way of having a record, having a disparate network and not having everybody in the network hear everything that's going on. And so just a little review how this compares with, let's say, Bitcoin, a public blockchain. Bitcoin has mandatory distribution. Okay, every single transaction that happens on the network is propagated to every single computer node listening on the network. Okay, it's mandatory that happens. That's how it works. Corda is the exact opposite. Nobody hears about transactions unless you are part of that transaction or permissions in. So you could be permissioned in later on for the example that I gave because you need the data. You could be permissioned in because you're a regulator and you're permissioned in and you're allowed to see these transactions that are happening. So there's different reasons, but it's not mandatorily distributed. Bitcoin and Corda both use this UTXO model, which is unspent transaction output. It's what we saw before with the change address, essentially. It's just a way of keeping track of the ledger, the accounting balance. And then in Bitcoin, of course, you can only add very small amounts of data to the token itself. So there's something called like a colored coin, which you might have heard of. It's just a way of kind of attaching some metadata to the coin. But it's very limited in scope, and that's why you can't have smart contracts and things like that on Bitcoin. Corda is implementing, they call it state objects. It's just a smart contract, basically. It's automated business logic. So that's built in as well. And the whole idea here is one of the big goals this is trying to solve is reconciliation is a massive time suck and money suck in the financial industry, and having a single set of records is much easier to do clearing and settlement in a reconciliation project when everybody is appending information to the same thing. All right. Any questions on that section right there? Cool. So just one other guy I want to touch on that I don't know if he's actually at the company still, because I saw he was working for another company too recently, but this guy Ian Grigg, so 2 podcasts actually. Ian Grigg on his own, awesome podcast to listen to. He's been into cryptography and kind of the digital currency space since before Bitcoin actually. So these digital currencies that weren't decentralized, he was working on those way back in the day. He's credited with coming up with triple entry accounting and also Ricardian contracts. And the reason I bring him up is because I want to talk about a Ricardian contract for a second. The name came from this, I think it was a project or company he was working on called Ricardo back in the day when the internet was first starting to build up some traction. He was experimenting with how to get bonds, how to put bonds on the internet maybe, and how that would happen. And he found that, well, in all contracts, including a bond, there's the legal prose, the natural language of what makes up the contract, what we're agreeing to. And then there's also parameters, and the parameters are really easy for to code up. It's a set, parties, date, value. It's easy to do. The legal prose is much more difficult. It's tough to turn that into code for a computer to understand. And so he had come up with this idea to, instead of this was alluded to earlier with smart contracts. There's no legal precedent on a smart contract right now, right? It's never been brought up in a court of law, and so how much weight that contract holds or how legally binding that contract is still really up in the air. The DAO is one of the first circumstances of a smart contract kind of having this bug that affected a lot of people, and it was a lot of money in there, but everybody basically got their money back, so there's no arbitrage state kind of happening. But we've yet to see kind of a smart contract that has a lot of money in it go wrong and people don't get their money back, and people are up in arms, and there's no clear resolution path there. And so one of the ideas he had to help kind of how to turn legal contracts in present day that have legal precedent and put that into digital code and kind of track that around on a blockchain or distributed ledger is this thing called a Ricardian contract, which is essentially you would take the whole contract and run it through a hashing algorithm so that you just have this fixed set of a hexadecimal number, and then you use that and you move that around, and then any time that an issue comes up and you would need to see the legal prose, what's actually there, you can just unbundle it and read the contract. And so an analogy is it's like a shipping container. It's like you put the contract in a shipping container and then you move the container around wherever you need to, and then if you need to see what's inside, you just open up the container and you can read it, and you don't have to hard code in all this legal prose, which is very difficult to kind of come up with conceptually. And he has the podcast, as I mentioned, he talks about this and a whole lot of other points, also talking about just general smart contracts and kind of ways to arbitrage resolution that he sees coming up. He thinks Ethereum smart contracts and the ones people are talking about today aren't really necessarily up to production grade or aren't going to hold water in a few years. So really interesting educational podcast I would highly suggest listening to. And if you're interested more about R3, those guys, Mike Hearn and Richard Brown that I mentioned earlier, they also did an episode together where they talk a lot more about kind of R3's initiatives and what they're doing within the financial space. Cool, so I'm gonna bring Solomon back up. We're gonna do one more section before you guys get into your kind of team project. Why don't we do a quick break just to give you guys a little breather. Oh, yeah, for sure.
Yeah, you talk about the smart contract and the legal contract. My question is, how do you ensure that the computer code is exactly doing what the legal contract specifies? Because each type of professional has their own expertise, right? Like legal, they know how to interpret legal, and then computer is programmed in that language. How do you know that the two things are saying the same thing?
Well, it wouldn't be that you're like hashing down a legal contract into a smart contract. It's more of a way of accounting for the contract itself, like that you and I have made this contract, and then keeping track of it moving around. Maybe like in his case, it was for a bond. So like, how do you keep track of where this bond is in the world? And that was like, it's the exact thing that you're kind of talking about. Is he's like, well, we have coders who are good at coding, keeping like an accounting record, and we have lawyers who are good at this, and that doesn't mix, right? So this was a way of kind of mixing it. Now, a smart contract, yeah, like how do you get all this into a smart contract? That's still a huge question. You know, this was just kind of a side alternative maybe, or like a good for now.
This was just a general question. Now, we went over the different platforms or blockchain. It's a hyperledger. The common denominator across the board is the proof of work concept.
For now, yeah.
Or it's a distributed side of it. So even proof of work is just one mechanism to get consensus, but the idea is going back to sort of like the very first slide where I showed that like BitTorrent. So it's the idea is that you have a bunch of nodes and they all see the same data. That's the core concept.
But the approach to the concept, my assumption is it's different for Hyperledger versus Ethereum, right? The consensus of how it determines which block is valid. So the question I have is, how do you trust the outcome of the proof of work that Hyperledger comes up with versus Ethereum comes up with? Is one logic more sophisticated than the other? Because the end result is the trust factor of the data integrity that's on the ledger. I don't know if I'm...
Yeah, I'm not sure exactly.
Is it apples to apples, or is it if I'm in a courtroom and I'm saying, you know, my transactional ledger, I use Ethereum, I can guarantee you it's fraud proof, I can guarantee that data integrity, versus Hyperledger.
Right, a lot of it is based on, I guess, history. So, for instance, people feel like Bitcoin is very secure only because it's lasted since 2009. It's been around 9 years. So that it has that going for it. But then on the other side, for the private world, at least there's a lot more oversight into what is happening. Not anyone can just get access to it. So you can always, if there is a problem in a private blockchain, you can always roll it back because you know who all the parties are, and you can be like, hey, there's a real screw up here. We got to take it back. So, but it still gives you that that guarantee that no one party can still change it unilaterally. Everybody has to come together, agree. Okay, we're gonna release this patch and all and upgrade.
Yeah, I would just add to that too. I guess there is, one depending on the use case, right? Because proof of work works really good if you want to have a distributed network where you don't have to know everybody, right? But in Corda, like the mining happens like that, right? Because I know who the parties are. I don't need this proof of work to make sure somebody's putting in some false information. And also, if you're comparing it apples to apples, like a public chain versus another public chain, you can look at some other factors too. Like if you have two proof of work public chains, right? Who controls the mining? Is the mining very distributed, or is there two mining pools who own 80% of the mining power, and then that's a less reliable chain in my view, than one that has a more distributed network. So I think it comes down to the use case at first, and then kind of diving into those particular protocols and seeing who's behind it, who the verifiers are, and things like that. That would, maybe one is a little more trustworthy than the other for a reason like that.
Is it true that only a certain number of miners have to actually agree?
You mean to like?
So it's a majority. It's not all of them, right?
No, that's why it's a 51%. Like they call it 51% attack, because just the majority has to agree, and then that's now the longest chain, and now everybody just works off that chain.
Majority hash power, I would say.
Oh, sorry, yeah.